Okay,
What's your first three initials? We have, it's an I, isn't it? Is there a P? IP. Did you label our segment IP? Okay. You probably have constructed perpendicular bisector before of a segment. Does anyone remember how to do it? Jeff? Where? How do you know that's exactly the middle? Okay. So put your sharp point on an I. And how far out does this have to go? 1.5 way. And then we draw an arc. So you can just hold your compass sitting, just move your paper. I found that's usually the easiest if you have one of the slippery ones. And draw an arc. Now it's very important when you lift up your compass, you keep the same width. Because where are we going to draw the second arc? On the other side. So carefully pick up your compass, put your point, the sharp point on P. Now precision is important in what we're doing today. So make sure you don't change the width and you're actually on point P. Take mine off a little bit. And draw a second arc using that same width. Those arcs should intersect twice. If the arcs don't touch at all, that means you didn't expand your compass wide enough. You didn't go more than halfway. They should cross twice. And then you take the ruler, line up where those two intersect. Did you get one of the crappy ones? It's not only a pencil, it's going to be another one. Line up your ruler where they intersect. Well, you need both, because you don't actually know what touches there. You need both the top and the bottom intersections. Okay, try one of these. Now, when you line up your ruler, make sure you're right on. The precision is very important. Oops. That is not what I wanted. That was on the line. Okay, I don't know what I was doing. What is going on? I have a line tool. Here we go. Okay. Now this line should go all the way through. And it's called a perpendicular bisector because two things happen. One, it bisects. Does all of you have a middle name? No. If you did have a middle name, what was your middle name? You can just give it the first letter. K. I think when I moved this around, my perpendicular bisector got messed up. When I was moving the arcs accidentally, my perpendicular bisector got messed up. So let's try this again. Okay, so IK is now congruent to KP because they bisect each other. So we should do a tick mark to show congruence with that one, and a tick mark between KP to show congruence. That shows that we bisected. How do we show that it's a perpendicular bisector? A right angle. So on K, at a bisector, we're going to draw in a square. Don't. You can go in the hallway if you feel like making airplanes. Okay, so now that we remind ourselves how to make a perpendicular bisector, we want to construct 3 on a triangle. Now it will get a little crazy with the arcs, so after we found a perpendicular bisector, we can erase the arcs so that it's not so busy. I need someone with 3 initials that are different. 3 that are different. Yeah. C, J, H. Okay. Let's Then one on the bottom, C. One on the top, J. One on the bottom right, the letter C, H. Hey, guys, I need you to stay with me. Pick up your pencil, please. You should have already done that. Oh, you did already do that. Okay. It was hiding, sorry. Label C, J, H. You need your name. Label C, J, H. Let's start with finding the perpendicular bisector of CH. Okay? Now, precision is very important, so make sure you're being very careful at your constructions, or what we need to happen won't happen. Okay, I'm going to start like we did before, on the left side. Put your sharp point there on C. Make sure it's right on C. And then you need to make sure you're... This is not behaving. There we go. Make sure you move this out more than halfway. A little line there I don't want. This front word is being really weird today. Is there anything? Eyeball it. Okay, sorry. Tom's reading this cardboard. This morning it was doing weird things too, and we have a faculty in here. So I don't know what's wrong with it. Okay. Make sure it's more than halfway, and draw an arc. I don't like that it's so skinny now. Okay, keeping the same width, relocate it over to H. And draw a second arc. This arc doesn't need to just cross once, it should cross twice. Otherwise, you don't know where exactly the perpendicular bisector will go through CH. You make sure you cross twice. No, you don't draw that right here. Use a ruler. Line up your ruler. You're not drawing the intersection right here. Now, it's very important to get right on the intersection. And then, oops. You should go all the way through. You need to draw that 90 degree. And we need to mark this segment is through to this segment now because we found a perpendicular bisector. Okay, next. If you want, you can erase the arcs because we don't need the arcs anymore, but don't erase the perpendicular bisector. Okay? Now, I'm already on H, so I'm going to make a perpendicular bisector for JH. Make sure you move out more than halfway and do another arc using H as your anchor point. Then you need to keep the same width and relocate your sharp point of your compass to J. So I'm doing JH right now. Keeping the same width. And then come put my sharp point here on J. And my arc using the same width should intersect twice. Then line up your rule from intersection to intersection. Make sure you're right on. This intersects JH at a 90-degree angle, so put the square. And a tick mark from J to the midpoint and from the midpoint to H. And then you can erase those arcs, because we have one more to do. You'll get a little too busy if you keep all the arcs on. Come on. Label those so that we have it on the board. J, H, and C. Then you do your arcs. Okay, once you have 2, you're ready to go do a third one. We need to bisect CJ. Make sure you're more than halfway. Draw an arc. And come over here to J. Keeping the same width. Draw an intersecting arc. This arc should intersect twice. Once you have those 2, use your ruler to connect and go all the way through the triangle. Oh, shoot. Oh, I have issues today. So you take your ruler and go all the way through the triangle and keep going. This one you have to keep going. And if you've done everything carefully with precision, what should happen? Okay, so you got that one, and that one you need to do with this one. So you can arc here, and arc here. And everything with precision, what happened on the perpendicular bisectors? They all intersect each other at the same point, don't they? Also, let's put in the box here, and congruence. I'm going to make this one a 3, so I have different tick marks. That's probably better. This point where they all intersect has a special name. It's called the circumcenter. Would you label them, please, as the circumcenter? Label it circumcenter. Now, if I take my compass and put a sharp point on the circumcenter, I would probably need to change the view in order for you to see this. Let's go back to 100. If I take my sharp point and put it on the circumcenter, okay, and I take the width so that it's right on one of the vertices, I really can take any of the vertices. I can put the width out to C, J, or H. And if you measured everything perfectly, watch what happens. Once again, sharp point on circumcenter. The pencil is on one of your vertices. Oops. So what happens? How many times does the triangle touch the circle? 3 times, and exactly which spaces? The points we have a name for that, so it would be, vertex, plural vertices. So what we found when the perpendicular bisectors intersect, that point is the center of the circle at which the circle will touch the triangle only 3 times. Exactly 3 times. Not less than, not more than, but exactly 3 times. Well, then you weren't equivocally precise when you were doing your constructions. So, any is great. No, what's your thing? From our circumcenter out to C, what is that called? Radius. From our circumcenter out to J, what is that called? From our circumcenter out to H, what is that called? A radius. So we found the one point, there's only one point in existence, that is equidistant from C, J, and H. There's only one point that exists that is equidistant from C, J, and H, and that's called the circumcenter. And at that point, we have the center of our circle, so that a circle with that radius length will touch C, J, and H, and only touch the triangle in those exact 3 places. That's called the, really right on the side. So this compass is giving me a hard time today. Move, come down here. And read this. Okay, so would you write on the side, please? The circle is, we have a word for the circle going around the outside. That is called circumscribe. The circle is circumscribe. Circumscribed around the triangle. So the circumcenter is the center of that circle. Circumscribed means the circle goes on the outside around the triangle. Circumscribed on the outside. Okay, let's move over to page 2. Construct an angle bisector. This one you should have already been introduced to. Let's see, if they could, give me one letter, please. J. Okay. This is angle J. The vertex is at J as well. We're going to bisect this angle. When we're bisecting an angle, where should we be cutting it? In half on the outside? On the inside, halfway. Okay, so how do we cut this in half? Does anyone remember how to do a construction for perfect angle bisection? What's the first step? Sharp point on J, okay? And actually doesn't matter. You don't want to go too big. You also don't want to go too small. Just a little bit is good. Just right. And then this arc needs to cross twice. Then when it crosses twice, you're going to pick up your compass using the same width. Again, precision is important. Don't change the width. You're going to pick up your compass, and you're going to relocate it to one of the intersections. Sharp point on one of the intersections. I'm doing the top one first. And you're going to draw an arc in the inside of the angle. So your second arc is just on the inside of the angle. Then you're going to pick up your compass and put the sharp point on the other intersection from the beginning. And this arc should cross with the second arc. So keeping the same width to make the first arc, keep the same width, pick it up, put it on the one of the intersections, either the top one first. Take it back inside with the same width, pick it up, put it on the other intersection, make an intersecting arc. And where those arcs intersect, you're going to line up your ruler from J. Oops, that's all I want. From J straight to the intersection. Okay? And how do we notate on the picture that those angles are actually congruent, the two smaller angles now? What are the things? Arcs. Now, since I have arcs everywhere, I'm going to do an arc with a tick mark and an arc with a tick mark. You can put tick marks on your arcs as well. Those are now congruent. Okay, so down below we have a triangle. We are going to find another interesting relationship that happens when we bisect all three angles. So we need someone else with three initials that are all different. Stetson? Lots of J's in this class. Okay, S, J, H. The S in the bottom left, J. Can we use your last name as J-H? Oh, it was Christian. Christian, do you have a J in your name? Ah, and an H, huh? So C-J-H and S-J-H. Okay, let's start with angle S. So put your sharp point there, your anchor point on the vertex S. Then we don't need this to be super huge or super small. Just a little bit. Just right. Just a little bit. It doesn't even have to be like halfway on the segment. Just a little bit. Make sure it intersects twice. You need to intersect both sides of the angle. Then carefully pick up your compass. I'm going to start on the top intersection. Put that sharp anchor point there on the top intersection. And make another arc in the middle. And we pick up our compass one last time, put it on our last intersection, and make an intersecting arc. Like so. Whoa. When you're ready, grab your ruler and very precisely connect S to that intersection. All the way through. Whoops, that is not a line. Let's try a line tool. From S all the way through. Okay, when you're ready, pick another angle. I'm going to do angle J. Oh gosh. Smartboard is being really picky today. I'm going to pick angle J. And then just do a little bit. If you want to erase those other arcs, you can. Because we don't need the arcs anymore from the last one. And then you won't get confused what arcs you're looking at. But don't erase the angle bisector. Angle J, make sure you intersect twice. Keep the same width. Repeat it to one of those intersections. Repeat it to the other intersection. Find out where they cross. Whew, barely made that cross right there. And then line up your ruler with J, and that intersection go all the way through. And you can mark that you get congruent angles now. One arc on the S for congruent. And once you're done, you don't need these arcs anymore, so you can delete them. Come on. And do a double arc and a double arc, so I know that's an angle bisector. And then there's the third one to do. You should know something interesting that happens. Okay, so bisecting angle H. Good. Make sure you cross twice. Pick it up. Draw an arc on the inside with the same width. Pick it up. Draw an arc on the inside with the same width that crosses. Make sure this one, oh, mine's off a little bit. I must have changed it somehow. I wasn't exactly on. But if you've done this perfectly, it should look like that. And then put 3 arcs here, 1, 2, 3, so I know those are congruent. Did a similar relationship as the segment bisectors happen, perpendicular bisectors? They all should have met in the same place. No. Okay, this one has a different name though, because this comes from angle bisectors. So put a point where all 3 of those intersect. This one's called the in-center. In-center. So the first one I did was perpendicular bisectors. That's called the circumcenter. You'll see why this one's called the in-center here in just a second. Now the incenter, we're looking at how far away is this point from JH. What's the shortest distance to JH? Is the shortest distance going like this? Is the shortest distance going like this? What would the shortest distance be? You're intersecting the line. The quickest way to get to... Okay, so if I have the water ball up here, what's the quickest way for the water ball to get to the ground? Drop it straight down, and it would intersect the ground at one angle. Nope. No, I'm just going to drop. There's no initial velocity with it. You just drop it. 90 degree, perpendicular, is the quickest way to get there. So, let me erase this carefully. And I'm doing is dropping altitudes, perpendicular, from the in-center. Okay? The SH, that one will look pretty much straight down. And this one, altitude, now if you put your compass with that anchor point on the in-center, and you spread it out so that it actually goes right to the perpendicular intersection of the altitude there. Let's do green. There we go. I off a little bit. I don't quite get it on. These come down. These come in. Aha, there we go. There's no circle this time. It's inside. Last time the circle was on the outside, and that was called circumscribed. This time the circle is on the inside. So the circle this time is inscribed. And the center of that inscribed circle is called the in-center. Okay? And the circle touches the triangle in 3 perfect places. One right here. Notice it's not on the angle bisector line. The angle bisector should help us get the center of the circle. One right here. And one right here. Okay? And those, it only touches in exactly 3 spots. So the in-center is the center of our circle inscribed in the triangle. Write this down, please. The in-center is the center of the circle inscribed in the triangle. The in-center is the center of the circle inscribed in the triangle. Circumscribed means on the outside. The center is the circumcenter. Inscribed means on the inside. The center is the in-center. Okay? Any questions? Okay, flip over to the last page. No, that's not last page. The one that says midpoint, mid-segment. And there's a typo. I put mid. It's mid-segment. Mid-segment. Okay, we've already learned midpoint vocabulary and mid-segment vocabulary. If I have a triangle, where are the midpoints? Where would the midpoint on this triangle be? Yeah, in the very middle of each side. Okay, what are the midpoints? What is the mid-segment on a triangle? And that would make, we have 2 congruent segments there, 2 congruent segments here, and 2 congruent segments there with 3 tick marks. What are mid-segments? The middle of one line segment. A midsegment is created by joining what? The midpoints, two midpoints. So you first have to know that you actually have midpoints, and a midsegment is created by joining those midpoints. There's that one there. Very good. And remember we learned that this midsegment is parallel to AB, and what's that midsegment's relationship to AB? Lengthwise, it has a relationship. It's half. Remember we did this triangle thing? We folded it, and it was half. Because if you fold this in, they meet each other perfectly, and it's the same length on the bottom as is the top of the rectangle, half. So the length is twice the length. So this midsegment is parallel to CB, and it's half the length of CD. This midsegment is parallel to AC, and it's half the length of AC. Okay, today we're going to throw in a new one called a median. You've heard of median in statistics. What's median in statistics? Yep, your data is lined up in order, smallest to greatest, and it's the middle one. You work your way in. It's the middle one. When you drive down the road, the cement barrier in the middle of the road is called a median. It's in the middle of the road. Okay? So this is a median is in geometry is a segment whose endpoints are a vertex and the midpoint, the midpoint or middle of the opposite side. A segment whose endpoints are a vertex and the midpoint or the middle of the opposite side. Okay, so first we have to find all of the midpoints. We've already done a construction today that helps us find the midpoints. How do we find the midpoints of the sides of the triangle down below? How do we find the midpoint? One of our constructions, we've done two constructions. We've done perpendicular bisector construction, we've done angle bisector constructions. Which one gave us the midpoint of the side? The perpendicular. Okay, anyone have the three initials that are different? What do you use these as well? Or Brianna? EKP. Alright. Label B out here on the left. K right here. And P right here. So, finding the midpoint is almost all of the exact same steps as the perpendicular bisector, except for you don't draw the line. You just mark the midpoint. You don't draw the whole line. So, get your compass out again. Let's start with BP, finding the midpoint. Okay, put your anchor point on B. How wide again does this have to go? There we go. A little more than half. Just eyeball it, make sure it's more than half. Draw an arc. Okay, Aria, now what do we do to finish? Do it on the other side. Keeping the same width. Don't change your width. Put your anchor point on P. And make sure you intersect twice. Now this time, we're not going to draw the line that connects the two. You're going to just take your ruler, line up from intersection to intersection to the point. Okay, now I can't actually touch my ruler to the screen or we'll draw some stuff I don't want. So I'm going to draw the line, pretending it's my ruler. Make sure you're exactly on. And then draw the point is all we need where you would cross BP. So you don't actually have this line, because that would be your ruler, and all you need is the point. After you have that point, you can erase the arcs, because we're going to have more arcs, and we're going to go too busy if we keep all of them on. Right. So all we really have is B, this point, and P. Who else has three initials that are different? I only have, I have three initials, but I have a repeat. Tyson, you have it? Three different initials? What are your initials? T, oh, we have a P already. So we're going to have to go with something else that doesn't have a K, a B, or a P. No one? N, H, M. So let's call M as in, yeah. Okay. Let's call this M. So we would mark BM is congruent to MP. Because we found the midpoint, so that should make two equal congruent segments, right? Okay, time to find the midpoint of KP. I'm already on K, so I'm just going to rotate this over. Make sure that I'm more than halfway. Draw an arc. It's important to keep the same width. Oops. And if you do what I did and mess up the width, it's okay. Just put it back on and remeasure. A little bit off. Okay. And then re-rotate it over here. Make sure you're right there on the vertex. Oh, dang it. Move the pencil, not the picture. Okay, line them up, but you don't have to draw the line this time. Just carefully line them up, and all we need is the point of intersection. Right there. And you can erase your arcs. And let's call this one, oh, and I don't need my line anymore. We can erase the lines. That's just pretending to be a ruler. Then call this one H. So I've got a double tick mark. KH is now congruent to PH. One more to do. You should know the drill by this point. Make sure it's more than halfway. Draw your arc. Pick it up. Okay, relocate it. Connect them with your ruler, but don't draw the line this time. All we need is the point, the midpoint. Oops, doesn't know that. And this would be N as in Noah. And then we'll mark these congruent segments with three tick marks. So we found all three midpoints. Now if we connected midpoint to midpoint, that would give us what vocabulary word? Midpoint to midpoint would be a mid-segment. This time we're going to median. The definition that we just wrote down said we have to connect the midpoint to what other part of the triangle? The opposite vertex. So with your ruler, I'm going to go from N and connect it over here to P. I'm going to go from H, connect it over here to B. I'm going to go from K, connect it over here to M. Now if you were precise on everything, it should come out that all three have another quirky relationship. This happens every time. They should intersect at the same point. Now, depending on what type of triangle you do, just FYI, sometimes these points are inside the triangle, sometimes these intersection points are outside the triangles. And it just depends what type of triangle you're working with, whether it's inside or outside. Okay, now this point is called the centroid. Centroid. Now there's an interesting relationship that's happened. So I get a highlighter out here. Other than, again, they intersect at the common point. This distance, oh, dang it. Highlighter. This distance is compared to this distance. This is the centroid right in the middle. No. Isn't the yellow one longer than the teal one? Yeah. Now there's a ratio that will happen every time. What do you think this yellow length is compared to the full K to M? To K to M. K all the way down to M. 2/3 is exactly right. Yep, you got it. Good job. So, we need another point. Let's call it, will you see it? Let's call this is a highlighter. Let's call our centroid C. So then C to M, if K to C is 2/3 of the whole, then C to M must be 1/3. This is a relationship that will always happen. So, K to C is 2/3 of the whole. The whole is K to M. Isaiah, write this down, please. CM is 1/3 of the whole, and the whole segment was from K to M. So, how much bigger is that yellow segment, the KC, to that teal segment, MC? The yellow segment to the teal segment. If the yellow segment is 2/3 the original, the teal segment is 1/3 the original, how do you go from 1/3 to 2/3? You double it. It's twice. Okay, so KC is twice CM. You need 2 CMs to be 2 of the teals right here to be equal to the yellow. This happens everywhere. If I take another segment, BC, that centroid, B to C, is how much of the whole B to H? 2/3. Isaiah, please stop doing that and write this down. Okay? The longer portion will always be 2/3, which means our shorter portion, let's do this one in green, from here to here, from C to H, okay, C to H is 1/3 the length of BH. Okay, and BC, how many CHs, that green segment, how many CHs, the green segment, do you need to be the same length as the purple segment? How many of these green segments do you need to be the same length as the purple? 2, so you have to times by 2. Meaning that green segment is half the length of the purple, and the purple segment is twice the length of the green. Okay, and there's just one more that we haven't done. I'll do this in crayon on this. This long one, from P to C. PC is again 2/3 of which segment? What's the full length? What was it, honey? NP, good. Okay, and new color. N to C is 1/3 of what length? The whole thing. N to P. So along this side, PC, you need 2 NCs to be equal. Okay? So, I'm not giving you homework on this part tonight. There's no new homework other than 2 things that are due next time. What are the 2 things due next time? Green packet on solving similar triangles, and the yellow, the relation worksheet. We also tutoring tomorrow after school being help on them. They should be done by Wednesday. Do you realize this is the last term of 10th grade, but if you go through this term, we are halfway done with high school. Because life grade counts. So I hope you're keeping track of your grades because you're halfway to high school graduation. So make sure you don't have to be filling out packets at the end of your senior year just to graduate. Okay? Please bring back calculators, and when you return the compasses, please be kind. Don't throw them in the basket. Gently place them in the basket so they don't break.